Hi, so this is the Big Data Lab 2, and this video is going to be a little long, so sorry about that. First to use Hive, I've already started Hive, and I made sure that my heroes table is deleted so that I can just copy and paste these commands that I've already tested. Now, here's the first one to create the table itself. Then we're going to load in data. This data was taken from Kaggle. It's the hero data. We're loading it in from this path. It worked. This is what the data looks like if you wanted to see that. It's the Hive. It's the CSV file, sorry, not Hive. My first query is getting the heroes and grouping them by their publishers. So we'll just go through the map reduce. It'll take a little bit, but yeah. I'm only getting their name because I didn't want to type too much the first time. Their publisher, and then each of them is going to be grouped by their publisher and by name. And there we go. See, here they are, all the Marvel Comics superheroes, all the NBC heroes, sci-fi, Star Trek, and so on. And they've all been loaded correctly. I'm just going to paste this and then talk about it. So as you can see, I'm selecting the name, I'm getting their height from the heroes table. I'm only getting the girls, and then I'm ordering them by their height, descending. So because it's descending, that means it's going to be tallest to shortest. So essentially getting all the female superheroes tallest to shortest. And here you go. So as you can see, it starts off tall and then slowly works its way down to short. I don't know why the data had negative 99s, but that's really is what's in the data. See, negative 99. Not too sure why. This next one is selecting their name, their alignment, their publisher from the heroes table. We're grouping them by their alignment and then also ordering them by their publisher. So it should do it alphabetically by publisher. Oh, there it is. So yeah, you can see good superheroes, bad superhero, bad, good in this one. And then each of their alignments, it's all in alphabetical order, so P, then R, then S, then T, then W, so works. Pasting this next one. This is selecting name, gender, height from heroes, order by height, and then limit them to 10. So this is going to be ascending because it's automatically ascending. So top 10 shortest heroes, I guess we define it as. So here you go, our top 10 shortest heroes. And then lastly, we're getting the name, their race, their height from the heroes table where they're taller than 100. I can't remember if this is going by centimeters or meters or what the what it is exactly. It's feet. But also that was my roommate if you just heard her. But yeah, it's just going to do the top. It's just going to get the more than 100, and then they're ordered by their height ascending, so it's still going to be the smallest, so it should be at least 100 and then increasing, so 100, 101, 102, 103 smallest. So as you can see, 108, 122, and then it just increases all the way up to 975. And those are my Hive queries. So Solr, you have to exit Hive first and remember to use your semicolons. Yeah, please just ignore my roommate. Solr control CTL config, create hero config, and just go through. I already ran this once, so I'm just going to add a 1 to each of these parameters so that it'll be a little bit different and I won't get errors because it is already created and we don't want that. So here's the first one. This is setting up the configurations. No problem. This is creating our directory. And then the collection within our directory. Once that is done, yep, we have it within here. And here it is, here new one. So this is our new one that we just made, and then we need our data to be added. So CSV file is the easiest because it's just a comma separated file and you can create it in a text document if you really wanted to. Oh, here it is. I sort of created this one myself. I kind of used the old book data and then I added a new thing called subject and a new thing called category, and I changed it up a bit, added movie, and then added features, added a popularity field too, just to make it a little bit different from the one we had in our lab in this class. So you just paste it into this file, make sure it's CSV, and then submit the document. Once you do that, you should, let's just ignore that. It should be success here. So if it wasn't a success, then you'd have like a special message. Let me just change this to something that's probably not accepted. There. That's not a real field. See, it would have had error field, bleh, doesn't exist. Then for queries, you go down to here to query. Can't really see it because my screen's messy. Just trust me. And then you type in your fields in here. If we just leave it alone like this, it'll bring everything. It's sort of a select all right now. Sorry, I'm gonna close this now since I already showed it. Save. And then here we're going to have our queries. The queries are, sorry, I have to look at them again. Oh yeah, category. Yeah, so, oops, wrong field. Category book, and then I want to filter by another thing, and it is going to be subject war. So we only want the books about war here. So if you do that, we got 2, and here they are. Our next one is going to be movies again. Sort by our popularity descending. So we're going to get our most popular movies first to our least popular movies. So as you can see, it goes 9 and then 8. And so it is in order. Next one is, wait, let me make sure. Yeah. We're only getting our popular movies up to the 3rd rating, so I don't know, I guess we'd consider it 3 stars out of 10 or something like that. Or so here is up to 3, then 2 which is less than 3, and then another 2 which is less than 3. So that one worked. 2. I added a few more when I did this earlier, but there. I think this is it. Nope, that one does not exist because it's not within those. So this limits it by how many words are in between them. So the distance. So if you do 2, obviously nothing exists. But if you do 10, you get these results. So it does exist. And then we want media that begins with fan. And I'm sure you can already guess that this is going to give us our fantasy. So, as you can see, we get our fantasy genre in here. This is the Solr tutorial. Now next is going to be Cassandra, and I'm going to pause for a second. I just wanted to close my stuff that was running. So you type in Cassandra and you get the shell here. Just give it a moment to boot up. There it is. And it accepted it. And then we're going to use spot 1 as our key space, and it works. And let's see. We're going to create our table. Here are all the fields and what type they are, and then our primary key is going to be our ID. Now we are going to copy the data into this table from a file. So we're going to copy it from my features DF, which I got from, this is a Spotify dataset that I got from Kaggle. So it's a music, apparently it's Spotify, but it's also music. So here it is. This is the Spotify use case if you hadn't gotten that idea yet. We're getting all the names of the songs and then the artists, and we were looking for Ed Sheeran, so we got it. Also, you have to allow filtering because we're not looking for the primary key, so whenever you do that, you have to add filtering to the end. Here is our next query. We're selecting our name of the song, the artist, the duration, and we're trying to get longer songs. So these are all the longer songs by milliseconds here. Whoopsie daisy. Next one is going to be we're getting loud and lively music. So we're getting the name, the artist, again, loudness, liveness, which is I think supposed to be liveliness, from Spotify, where the live, oh wait, yeah, I got smaller, loud, sorry, I meant quieter. That's not loud and lively, that's quiet. Whoops. Yeah, so the loudness is going to be less, smaller, and the liveliness is going to be smaller. So it's actually quieter music and more calm down. So, and those are my 3 examples to use for this use case. So as you can see, you got the songs, and I guess Spotify would use this if they were trying to get people their kind of music quickly, because how Spotify works is sometimes they try and give you songs related to what you're listening to. So if you're listening to this artist, they start playing other artists that are similar to it. It's a lot like Pandora in that way, except you can also create your own playlist with specific songs in mind. And yeah, I think that's about it. So thank you for watching. I hope I didn't ramble too much. Bye.